Okay, so today we've got something to download from Learning Suite. So, weatherdata.zip. So it's actually a zip file. You want to download that, extract it. Have I extracted this yet? I haven't extracted it yet, so I'm going to right-click and extract all. And let's talk about this data. The whole purpose of what we're doing today is we're learning how to parse text files. This is a step in the direction of what we're covering next week, which is how do we control Internet Explorer? How do we tell Excel to open up Internet Explorer, go to a website, find where it says username, put in the username, find where it says password, put in the password, find the submit button, submit, go to the next page, find the data we're looking for, extract that, and pull that data out. A big part of doing that is being able to look at the HTML that the server sends to Internet Explorer and be able to figure out what data we need. Well, HTML data is just text data. And that's what we have here. So this is kind of a special case of, or HTML is kind of a special case of what we're doing today. But let's take a look at the X11 file here. And I'm going to open that in Pad. Are you home? This computer is supposed to be somewhat fast. It's i7, it's only 7th generation, but still, it's an i7. Now maybe we'll open Notepad++, which is the default. While that's coming open, hopefully some of you have opened it already. What I'd like you to do is look at this and tell me something. I was about to say intelligent, but intelligent is too high of a bar. Tell me something, I think even interesting is too high of a bar. When you get that file open, tell me something informative. There we go. That's a good word. Say something informative about this file. I'm going to open it like 3 times. Oh. So, you can say something about this file. I mean, something. Okay, so there's some structure to it. So that's good. That's good news. We've got some structure. If there's some structure to it, we might be able to do with the data. But what kind of data is this? Can you say anything about the data that we're looking at? So it's precipitation, precipitation tabulation. So we're looking at rainfall amounts. Anything else? It's from the year 2008, and this is particularly from the November of 2008, so November 4th through 10th here. Somebody must have served their mission in Brazil. You did. So say something about this data. This might help.
We have a Brazilian here.
We have someone who lived in Brazil.
Yeah.
Say it.
Well, that's a bunch of Brazilian cities.
It's a Brazilian city. This is precipitation in Brazil for November 2008, from November 4th to November 10th, 2008. Yeah. And so we see. Sorry for putting you on the spot. Maybe it's been a while.
Sounds like it's Brazil.
Those sound familiar. They weren't in your mission, so you're off the hook. They weren't in your. Those are not cities in your mission, so you never served in these areas. Okay. So we have kind of 2 blocks of data here. So what we have here is like this is a city. Is this a state? Is this a Brazilian state?
Yeah.
Okay. So it's a city and a state, and on June 8th they got. Let's look at this one. I'm not quite sure how to read this. Anyway, here's 13 millimeters of rain, and that was 42% of normal. Here they got 55 millimeters of rain, and that was 149%. Holy cow, 242%. You'll get out the waiters because that was a lot more rain than we were expecting to get on that day. So, we're not so interested in this data. The next segment, though, is the raw data. So this says we got 9 millimeters of rain on November 8th, 2008 in January. I'll say it like a gringo, January. I'm sure that's not how it's really pronounced, but that's how we'll say it. And we got 0 on the next day, we got 8 on the following day, and we got a trace over here, and so forth. What do you suppose this one is? Probably not reported. For some reason we don't have that number. That's how they represent that. Okay, so we'd like to be able to graph this data. Is this data in a format that's very graphable? It's terrible for graphing right here. So we would like to be able to kind of extract this out of this data that really is meant to be read by a human and just get it into some raw data format that we can then manipulate a little more easily. Now, you might ask yourself, why? Oh, why? would you ever get data this way in the first place? And there's a really interesting story as to why this data comes this way. I should let you know that in an earlier version of this class, I used to have students do a final project where they would have to find a project and do the work. This was one student's project. This student's father had to tabulate this data every week or something. It kind of came in, and he would get hundreds of files, and he had to work through it and do some analysis on this data. And so that student was automating the process. And I thought, oh, that's really interesting. So we still are kind of in at least the relatively recent past, this is from 2008, getting data out of systems in this way. So we set the Wayback Machine to like the 1970s. If you were a company and you thought, maybe I should get one of these computers, even if you're a big company, how many computers do you have in the 1970s? You probably only have one. And it was really expensive. And it's really expensive to run. And how many people actually get to work on that computer in your business in the 1970s? A few people that have propellers on their heads, right? These are like really technical people. They're not business people. They're technical people. They're keeping the machine running. They're moving tapes around and so forth. So how do you, did I tell me your name?
Seth.
How does Seth, who's the marketing manager, what's your major?
Statistics.
Who is he's the chief, what do they call those guys? Actuary. He's the head actuary at the company. How does he get the information off that computer? How does that information come to him? Do you know? It's before you were born. Do you know? Okay, so there might have been punch cards involved, but the punch cards are actually like the program. That's the data, and we're running it. That's not. We don't have to look at those cards to figure it out. That's like the instructions for the machine. How's Seth going to get his data? You don't know. That's awesome. Every Monday morning, someone comes around with a cart. And he gets to Seth's office, and he goes, Seth. And he takes out a printout for Seth that printed over the weekend, and he puts it on Seth's desk before he comes in. He comes in Monday morning, he's got his printout for the week. That's the data he needs to do his job for the week. That's how you got your data. The 1970s were awesome. And so it was a world of printing. Now, today we think about, we've got a computer system, how are we going to get data in and out? We're going to share data around it. Do we think about moving data from one computer to another computer in the 1970s? No, we only have one computer. And most of the folks we know don't have computers. There's no internet. What would we do with data? I mean, if we had to move it, what would we put on a tape? We take another computer and, put it on the tape. But this idea of saying we've got some way to have a standard format that we use to transfer data to be able to bring it into Excel hasn't been invented yet. So this idea of getting data in and out, it's kind of still in the distant future. So now let's go forward to the 1980s. Now we have, some of our folks, some of our actuaries now are going to have personal computers. But they think, okay, I've got my own computer here in my office, and I might have to get the data in on a floppy diskette, but somehow I'm going to have to get that data into me. If I can get this data electronically instead of on a printout, that would be awesome. But there's no floppy diskette on that mainframe. How are we going to do it? And the only way that we get data off this machine is by printing. Someone has a great idea. I mean, if you think about the way that a page is printed, we plug a printer into the computer, and we say, print it to this port. And we say, print space, and that print head moves over space. Print a space, space. It happens faster than this. Print a space, space, space. W, prints a W. S, prints an S. I. And it goes, it happens a lot faster than that, but it goes through, and that's how it prints. And someone said, what if we invented a printer that could plug in and could say, print an S, and it would go, okay, I'm going to print an S. And instead of printing onto a page, it wrote it to a floppy disk. What if we could print to a file instead of printing to paper? Then we could take that file and then we could give it to someone on a floppy disk. They could put it on their personal computer, and they could do whatever they want to with it. And so when you look at this, you're going to look at this and you're going to realize, oh, this is a file that was designed to be printed, but instead was printed to a file. It's surprising how many large companies today still use this kind of old legacy system. We say legacy system, but what are the characteristics of the legacy system? It's mission critical. This software is running my business. And it's old. I guess that's what makes it legacy. It's old, we keep it running, we need it to run. It would be really expensive and really difficult to replace, and why replace it? It's working. By the way, who runs these mainframe systems? Really old people. They're dying, and they're retiring. And I guess graduates from our IS program, they start somewhere in the 70s, 60s, 70s, $80,000 a year or something. But I've got an associate who's on the faculty at the University of Tulsa, and they have one of the few mainframe programs. You want to learn how to be a mainframe administrator programmer? You go to the University of Tulsa, they'll teach you to do that. And all these companies that are losing their mainframe people are going, we've got to find mainframe people somewhere. We're going to get them. We're going to get them from the University of Tulsa. What are we going to pay them? $120,000, $130,000 a year coming out of college to start. Just because supply and demand feature. We offer a mainframe. If we were to offer a mainframe class here, we don't take it because we look at it and folks look at it and go, it's like old technology, dying technology. Why would I do that? Well, because someone's going to pay you a lot of money. Anyway, the point is, there are big companies with this kind of software that's still running, and it's in such a situation that they're paying a premium to get people to be able to do this. That's where. So, what we're showing here, it kind of has its origins in the 70s. This file came out and was in production less than a decade ago, and this kind of thing is still happening all the time. All right, so our task then for today is to be able to look at this file and extract out raw data for these precipitation numbers. And so if you're looking at this thinking, oh, I'm probably never ever going to do this, you might be right. But the stuff we're doing today is going to help us on our way to being able to work with HTML data, which is just a special case of text data as well. So let's go ahead and get started. So let's get over here to Excel. I'm going to make a new file. New, hopefully it won't take forever. New workbook. I'll go ahead and save this. And I'm going to save this, I'm going to save it right there in the same folder where I extracted that weather data. Hopefully I can find weather data. And XLSM. And I will call it parse PRSE text winter 18. Bless you, my son. Parse text. I'm going to insert a new module, and we're in good shape. Okay. So, in reality, kind of the whole part of what this solution would be is let the user pick the folder that's got the data, iterate across all those files. We've done that in prior examples. And so let's just start off with a sub-procedure called, we'll call this the Acme sub-runner. It's going to call the procedure that we create that's just going to process one of these files at a time. We're not going to worry about iterating across a set of files. We're going to worry just about processing the one file. So we'll have another sub-procedure called process one data file. We're going to pass it in a path to a file to open. And so then in our sub-runner, we will process one data file, and we're going to pass it this workbook path concatenated with a backslash and whatever that file's name was. WSI space 2008x11.txt. Okay, so we're kind of set up now. This sub-procedure is going to call this one and pass a path. We're setting it up this way so you get the point, is that you pass an arbitrary one of these files, or pass a path to one of these files in, and it will process that file. So, let's go ahead and open that file. So here's what we have to do to be able to open a file. We've done a lot of things with objects and methods and properties. But opening files goes back before the guys who made BASIC ever thought about using an object. And so the syntax is going to feel a little bit foreign to us. Here's how it goes. We're going to say open. We're going to tell it the path of the file that we want to open. That's getting passed in here. So it's going to be this parameter, open path. Now we got to tell it, what are we doing with it? What are we going to do with this file? Are we going to read data? out of the file and bring it into the program? Are we going to take something from inside the program and write it out to the file? Are we going to kind of read and write both of these things? We're going to do one file, both reading and writing? And the answer is, we just want this for input. We're going to read the data in from this file and then do something with it. So open the path for input, and then we give it a number as number 1. Now, in the object-oriented world, we would say, let's create an object that binds onto that file, give it a name, and then that's how we'll know we're talking about that file. But here, we might want to have multiple files open simultaneously. Can you imagine? Saying we've got to open up this file, we've got to open up this file, we've got to read data from both of these files, and we've got to write data out to this other file. Maybe we're going to read data from these files and create a comma-separated variable file. We might have 3 files open at the same time. How are we going to keep them straight? All going to have a different number. So when I want to read from number 1, I'm going to say read this from number 1, write something from number 2, read something else from number 3. So this number is how we're keeping track of which file that we're talking about. Now, as soon as you see the word open, what do you expect to happen somewhere? Yeah, so before we forget, let's put a close in here. We're going to close number 1. So we're going to open whatever file path we pass in as number 1. All right. Now, there's a couple of different ways that we could read data out of this file. One approach would be to say, just read the whole file, put it into a variable. Read the whole thing, put it into memory. That works pretty well if the files aren't too big. How much memory do you have on your computer? Seth, how much memory do you have? I'm never going to know, so just pick a number.
I think it's 4.
4 gigabytes. What do you think? Do we live in a world where we have files that are bigger than 4 gigabytes? Yeah, I mean, 4 gigabytes is about the capacity of a DVD, so it's about the length of, a Blu-ray, not DVD. Yeah, DVD, not Blu-ray. Anyway, yeah, but we have single files that are that big, easy. And so that's all the memory you have. You can't read that whole file in memory. And so another approach is to say, you know what, let's read this 1 line at a time. Lots of lines. Maybe we have a terabyte. We got a huge file here. Could we process a file that's a terabyte big on your computer with only 4 gigs? Sure. As long as we don't have to see the whole thing at once. Can we look at it and just deal with 1 line at a time? If so, we'll just do it that way. Read part of it into memory, deal with it. Read something else into memory, deal with it, and so forth. That's what we're going to do. And so let's go ahead and create a variable. We'll call it 1 line as a string. So we're going to read 1 line at a time. Here's how we read a line. Here, we say line input. We tell it the file number we want to read off of, number 1. And then, I meant to say comma. What happened? What has my computer done? Oh, mouse, come back. It's like my computer is dead. I tried to put a... Oh, it's coming back. Ooh, that was a close one. I have no idea what that recorded while we're doing that, but there we go. And then we give it the variable we want to dump that data into, 1 line. Now I should be able to say debug.print 1 line, and I should be off and running. All right, I'm going to go ahead and run this, and there it has. It's printed off that one. It happened so fast. It opened that file, read the first line, printed it, read it, the first line. Yeah. A bunch of spaces, WSI Corporation, a bunch more spaces. That's what I got. A bunch of spaces, WSI Corporation, a bunch of spaces. We got the first line. What if we want to get the second line? No sweat. Just read the next line. We could put it into a different variable. If we had to keep 2 lines around at the same time, we could put them in different variables. We could read it into an array. We could put it into a different portion of an array, whatever we're doing. But here we're just saying line input and then put it into some variable. In this case, we're putting it right over the top of the old variable. So if I run this, what's it going to print? Line 1 and line 2? What's it going to print? Yeah, just line 2. Because 1 line is going to take line 1, and then we're going to read the next line in. It's going to go right into 1 line. What happens to what used to be there? Poof, right over the top of it. And then so it should print the second line. And so there I've got my second line. All right. So that's the mechanism to be able to get at this data. So now the question is, what data do we need? So I'm going to come over here to my workbook. We're going to need state. So states there are cities, date, and precipitation. there's something called call. So some kind of number of the thing. We're going to skip this. This doesn't let us do anything new and interesting beyond what we're doing with these other ones. So we'll skip that. We'll just pull in these. Oh, my computer is so slow. I'm almost wondering if it's worth time pausing and doing a reboot on this. Okay, so we're going to get those. What's these four things? State, city, date, and precipitation. So we're going to say, all right, in Sao Paulo, we're going to have some city. Is Sao Paulo a state?
Yes, it's a different state and a city, not in the same place.
Ah, good. Now we've got the local information.
So Sao Paulo wouldn't work with the data that we have. Belo Horizonte.
Now that would be someone who doesn't know the data so much, because I knew it was a state. Because it's the next page in our data. We got lots of data here. So we've got Sao Paulo. Oh, and Sao Paulo's a city, so that's really interesting. So I don't even think so much. So we've got state Sao Paulo, city Sao Paulo, date. We've got the date and the amount of precipitation. So if we look at just one of these lines, for this line, how many rows in Excel is that one line going to generate? I've got one line here. How many rows will it generate in my Excel table I build it? 7. Because I'm going to say, so this is November 4th, 2008. I'm going to say city, state, date, amount. That gives me that number. City, state, date, amount, that number. City, state, date, amount, that number, and so forth. So we're going to end up, having just run this exercise, we're going to end up with more than 900 rows of data by the time we process this one file. And so the first trick is, where am I going to get the date from? I got to put here 13 millimeters of rain on November 8th in Sao Paulo. Where do I read the date? Any thoughts? It's ugly. Where does the date come from?
It says at the top there, on row 79, it says the date.
Yeah, I can tell that this is coming from the 4th to the 10th of November, so I can pick up my November 8th right here. My November 2008 right here, but the day of the month, I got to read from right here. And I got to somehow keep track of that long enough to be able to write that number. This is not pretty.
Couldn't you set that as a range, with 4 being 1 and 10 being 7, and then 4 there equals 1, so it would align the 4th? Do you see what I'm saying?
You know what? I know that you're thinking about something that sounds very honorable and good, and the answer is yes, that would probably work. We'll take a little bit different approach, but yeah, we're going to have to do something to pull these numbers and say these are the numbers we're going to work with. We've got to somehow match them up to these numbers. But the tough thing is we're dealing with one line at a time here. And we'll have to set up some other variables to keep track of some stuff. Do you see how this could be a little bit challenging? Fear not, my children. We will do this by the end of the hour. Well, not the end of this hour. Well, yeah, by the end of this hour, which would be 15 minutes after class is over. But we'll do it before we're done with class. Okay. So let's go ahead and just come and look right here. It turns out that we've got the days are here, but we've got our month and year here. This whole file is going to be the same month and year. In fact, look at this. Look what happens if you have data that wants to extend across 2 months. Look at this. Can we have a week that's in 2 different months? Yeah, you can totally have it. But look what happens when you have that data. It goes, no. We're just taking 3 days and putting it in this file. And the other 4 days that were in October, they're in a different file. So the good news here is that when it says November 08 here on line 2, that's the same November and the 08 for this whole file. So let's start off with that. We can pick up that information, and we don't have to do that but just once. So I'll do another variable. I'll call it moyr, M-O-Y-R, as a string. And good news, I've already read the first 2 lines, and so by this time, what I have sitting in line number 1 is I've got the line I'm after. It's right here. So how am I going to get the month and year? Talk to me in terms of an algorithm. You can still speak in English here, but it should be some kind of English that I can convert into SQ or convert into VBA without too much trouble. How am I going to get the month and the year? You as a human, you look at it and you go, aha, I recognize that. That looks like a date. Especially the NOV is what tips it off, for me here. The dashes, I figured that out. But VBA is not going to do that. You can't say, look and see if you can find something that looks like a date in here. So what algorithm could we use to tell it exactly how to get that month and year? Any thoughts? Sounds like your buddy's volunteering. You got anything?
He said mid.
Mid. Absolutely, yeah. So we're going to take mid, starting at that character, and we're going to take 6 or 7 characters. That'll be great. So step 1, mid, we'll extract something out of here. Now, step 2, we've got to find out where to start. How do we know where to start? One possibility is it always starts from the same place. Wouldn't that be nice? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Maybe it always starts at the 18th character. What do you think? You're shaking your head. Why?
Because the month would change.
Yeah, this month doesn't matter. But this month, looks like they're giving the full name of a month right here. And I can imagine that pushing things out. So no good. Starting at 18th character, bad idea. Go ahead.
Finding the first dash.
Find the first dash. I like it. Let's give that a shot. So we'll need something to keep track of where we found that first dash. So let me dim position. I'll just abbreviate it POS. That's short for position. It's an integer. I've got one line here with my data in, so I'm going to say position is equal to inString. Oh, I was going to ask you to come up with that, darn it. What function should we use? inString. So inString looks for the occurrence of one string inside another. It says start at the first character, look at, what should I look at? One line. Look for the dash. And that will tell me where that dash occurs. Let me go ahead and put a breakpoint in here. I'll just write it in code, stop. And I will run my code up to this point as a string. String. Okay, so now I should be able to ask for position. And what do I expect position to be? 18. Yeah, there it is. So it found that dash at the 18th position. Okay, so now we're going to use mid. Now that we know where to start, we can use mid and say, just give us the next 7 characters. So now I should be able to say mo_year is equal to the mid of one line, starting at position and taking 7 characters. I'll just go back and run that little line now on the, and let's look for mo_year. And I've got, a little more than maybe we needed. Dash November, dash 08. Actually, ultimately, what am I going to have to do? I'm going to have to take that 4 off the little header of the data and drop that in here. I'm going to need the dash there, whether I start with it now or not. The dash is going to have to be there. So let's leave it right where it is. So now I've got my month and year stored. It's the month and the year that is going to work for the whole file. We're feeling pretty good about month and year. Okay, so tell me what you're thinking. How many of you think, you know what? With a little bit of work, once we had the data in that one-line variable, how many of you think I could have got there on my own? Me and Google could have got there. It might have taken a while. That's okay. So yeah, I'm hoping that you're at this point you're feeling, okay, I've got some understanding working with strings, and it might take me a while, but yeah. So what we're about to do here in the next 40 minutes, 35 minutes. Don't feel bad if you think, wow, that would take me a long, long time to do, like a day or more. That'd be okay. So that's we're kind of seeing a new process here. Okay. So we've got month and year. So far, so good. What else do we need? What's next? So this whole part up here that looks like all this percent of normal, we don't need this data. We're going to try to skip past this block and get down to this data here, which has, let me come back to our longer one, which has the other part of our date. So the question is, how are we going to find this line? The computer has to look at every single one of these lines as we go through. We want to keep reading lines until we find one. Okay, so let's get the structure in place to do that. If we're going to keep reading lines until we find some condition, what structure are we going to be using? Yeah, do until something. loop. What do we do inside the loop? Well, we'll do events before we do anything else, in case we do something crazy. And we'll get out. Do events. And then we're just going to do a line input again. So inside this loop, we're just going to continue to read the next line and read the next line until we found the line we're looking for. How will we know what line we're looking for? We might find the next line after November. So what you're saying is, well, we know it's November here, so let's keep going until we find November. That would work. We'd have to have some conversion built in to be able to say we're looking at NOV, and so we're going to have to look for the word November. We've got to convert NOV to November. That probably wouldn't be too hard to do. And yeah, absolutely, we could scan, we could read each line until we found a line that started with November. It starts with some spaces, but we can turn those off easily enough. So it finds November, and once that happens, we know it's the next line. Good, that would work. It's more work than I want to do today. Do that part. Look for something a little more simple, something unique about this line, that when we got this line sitting in one line, we could look at that and go, there it is. Yeah?
Well, is it not possible to call it, I mean, clearly it knows what line, it knows that there are lines numbered. So it numbers the lines. Can you just not call it by the line number?
Oh, could we say jump to line 35?
Yeah.
And the answer is no. We can't just say jump to line 35. Here's the reason. To the computer, this file is one long sequence of characters. Let's see. We talked. It was some time ago. We talked about this when we were talking about each character gets stored in memory as a number. So A is capital 65, or capital A is 65. Capital B is 66, and so forth. There are control characters. So one of them is a carriage return. That's character number 13. So when we think about these old printers that we were printing to, we would say, send it number 32, and it goes, aha, printer goes, print a space. Well, space over. We say, now, we send it to 65, and it goes capital A, and it's capital A. We say, send it a 72, and it prints a capital N out of it. And then it gets all the way across, and we have to say, you know what, it's time for you to move the carriage back, start printing again. And that's a different character. We send it character number 13. And that says, move the carriage back. We then tell it, advance the paper. Advance the paper. And that's character number 10. We send it character number 10, and it goes, character number 10, advance the paper. So there are these non-printable characters that we use that originally were used for controlling how the printer behaved. But we do the same thing with it now when we have a file. So when we look at this text file, to you and me, we look at this and we go, space, 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 website corporation, end of the line, it comes down here. But this program had to know that that was the end of the line. And how did it know that? There was a character number 13 followed by a character number 10. And when Notepad++ opened it up, it went, I don't know, these characters are coming. Oh, look at that. Character 13, character number 10. Go to the next line and then keep printing the rest of the characters. And that's exactly what happens. That's exactly what happens in VBA as well. Is that it has to read past all those characters and go, aha, there's the carriage return. That's the next line. Now, if these were all the same width, if these were all 80 columns wide, then it could jump to the 35th line. We could just tell it, advance to this point and read right there. But they're not the same width. Because if you look at the data, here is a short line. I'm going to just right arrow over. And if these lines are all the same width, that's got a bunch of spaces in it. And I'll be able to go over to it. But as I'm writing, as I do a right arrow over, it says there's no more data there. It wraps down and goes up.
But could you count the carriage returns now?
Could you count the carriage returns? Yes, but how are you going to find the carriage returns? You don't know where they are. You've got to read each character to find the carriage return. Carriage return, carriage return. Yeah, so as tempting as it is to say jump forward a bunch of lines, you can't do it without reading the data. You have to read the data to get to those lines. Okay.
You just look for station?
Tempting. Maybe we just find the line that starts with station. That's pretty good, except, let's see, where are we? Well, that's the percent of normal. We're looking for this station here, but we'll have a red herring right here. And they kind of alternate back and forth, so station doesn't do it. But you're good. You're looking at the line for something that's unique, and here's what's unique. If it ends in norm. This is the only kind of line that ends in norm. We're talking about normal up here, but they have to abbreviate it even further down to NM. So we can just continue to loop until we find a line that ends with norm. So anyone here named Norm? You get a gold star today if your name happened to be Norm. Because Okay, so do until in string, looking at the first, no, not in string, what do we want? Write a one line. We want the rightmost 4 characters. We want to know if that is equal to norm. Does case matter? Case matters. And so this is going to, let's put a note here, looking for the raw data. And once we find norm, we'll know we have the raw data. So I'll just go ahead and come back up to this loop. I'm going to run across this loop, and hopefully one line will have our norm. One line will be holding that header line. One line. Yeah, there it is. We've got our 4 through 10. So we've scanned through until we found that line. Great, found that line that we're after. Now, this next part's going to be a little bit tricky. We've got to pull off 4 through 10 and say, that's our baby. That's it. We're going to use 4 through 10. For the next 7 lines that we write into Excel, that's the data that we're going to write with. So, how do we get that? Any thoughts? Go ahead.
Well, could we use mid and put it into an array?
Oh, I love it. Yes. Okay, so we can look at this and let's pull this out. Once we get those numbers out, if we could just figure out how to chop that up into an array, that would give us a pretty good structure that we can even iterate across. We've got this, we'll go through however many there are here, because remember, we've got some of these that are not going to have all 7. We can't assume that it's 7. Some only going to have 3. But if we can come up with an approach that would say, just pull that out, make an array out of it, let's do it. Okay, great. So let's make an array. Let's dim up here. In fact, let's do this as let's dim days as a variant. Ooh, variant. We use the same variable to hold the set of days that we've pulled out. We'll have to manipulate it a little bit, and then we're going to convert that into an array, and we'll use the same variable. So variant would be nice, because it's going to be a string one moment, it can be an array the next moment, and we'll do that. Okay, so now we've got our data. Look for the raw data. Okay. So now we're ready to pull that in. So days equals the mid of one line, starting at the 20th character and taking 40 characters. How did you know it was 20 and 40? Well, can't you just tell that's about 20 right there and that's about 40 over there? That's kind of tough to tell, especially because the spaces aren't the same size as the other letters in this case. But if we count over, you'll see I'm right. I mean, I just did this like a half hour. 20. So that gets us past that. And then if we take the next 40 characters, it takes us somewhere over there. So that will give us that data. Oh, now we probably don't want those leading and trailing spaces. How are we going to get rid of that?
Trim.
Yeah, trim. Trim. And so we just wrap a trim right around that. So you go ahead and process that line. And let's take a look at data. Let's see how well that worked. Did we run this? One line, mid of one line, starting at 20, taking 40. Oh, not data, sorry, dates. Data is the next variable we're going to. There we go. So there are our days. Now, what's the magic function that's going to convert this string into an array? Split? Yeah, there's a function that does that. Look at this string, cut it up based on some delimiter, and give me back an array. So the thing is, our delimiter can be multiple characters long, but it's going to be whatever we tell it to do. And here's the problem. How many spaces do we have here between 4 and 5? 1, 2, 3, 4. So that would be great if we could just say the delimiter is 4 spaces. Chop it up on 4 spaces. That would be perfect. But the problem is what? 1, 2, 3. They're not, it's not uniform. We could probably do something a little bit smart because we know when it's a 2-digit day, that's when it's going to be missing a space in there. But, any thoughts?
I have a question.
Yeah.
So is that 40 going to mess us up if there's only 3 days in a week, or is it the same?
So you're talking about this one over here.
Yeah.
Okay, so what we're, no, because you'll notice we're still starting right here at the 20th character, and we're taking 40. So we're getting a bunch of spaces, but we're trimming off all this leading and trailing space. So we'll end up with 3 values here, separated by spaces, and we just got to be able to make that into an array. But you're right, it'll be a different size array, and so that's why we want to say how big it is, make an array out of it, and then we can just ask how big the array is. That'll tell us how many entries we have. Question here?
Oh, I just have an idea for the.
Go ahead.
Question. What if you split it on 3 and then after you get that, you trim it?
Oh, so just split it on 3 and then trim.
Have extra space.
That's pretty good. So if we split it on 3, we might have some other spaces in there. We could go across that and then trim off what's inside. That would probably work, unless we have 6 here. If we have 6 here, that would be a problem. 1, 2, 3, 4. But we don't. If we had 6 there, what would happen? We'd end up with 3 here, 3 here. We'd end up with an extra day in the middle that's blank. So your idea will work really well. It's not the idea I thought of for the last class, and I'd like to be about the same. We're going to go with my idea. I like your idea.
Since we just used trim, couldn't we just use trim again and then use a single space as the delimiter?
Okay, so we just use trim again and somehow just tell it something about that. And the answer is trim in VBA. Trim only looks at data before, spaces before, and spaces after. Inside Excel, the trim function will do stuff inside the string as well, but not in VBA. So trim is no good. Let's take a look at the approach. Here's what I want to do. What I'd like to do is I would like to, I'll just do it right here so we can see it. I would like to say replace, I want to look at my data, I want to look for 2 spaces, and I want to replace it with 1 space. Let's see what that prints. So that's going to find these 2 spaces, and it's going to replace it with 1 space. It'll find these 2 spaces and replace it with 1 space. And so it should shrink this down. So now I should have, oh, this is interesting. This actually gives me now 2 spaces between each character, even these over here. I can now split based on 2 spaces, and that would work. That's kind of coincidental. But now I have 2 spaces between, so what I'd like to do next, I'd like to run this again, but now run it on the results of what we just had.
Can't you just run it on the null value, so replace the 2 spaces with nothing?
So let's do that in just a minute. We'll take that idea here in a second. Now, if I do it twice, then that's going to give me 1 space between each character. I want to do a little bit more general, and that is to say, just keep replacing 2 spaces with 1 space until 2 spaces aren't there anymore. And that's a little more general approach because it says, I've got a bunch of space. I don't know how much space there is. Shrink all this down until everything's separated by a space. That's what we'll do. But let's take a look at your idea here. Let's put some more spaces in some of these. Just look for 1 space and replace it with nothing, yes?
Yep.
That's pretty good if I know the width of my data. If I know the width of my individual elements. Because now I can just say each character is a different day, but the problem is,
1 and 0.
yeah, the 1 and 0 will get treated as different days. Go ahead.
Instead of replacing it with no space, line up the comma.
Okay, replace it with comma. And then I just changed the problem. I haven't fixed the problem. And now I've got a bunch of commas. So, making progress. Got rid of the spaces.
but then you can do it is text, or is numeric.
It's numeric. Yeah. This isn't making the loop isn't so hard, folks. Let's make the loop. Okay. So we're going to do until until what? Until in string, looking at days and looking for 2 spaces. It's kind of hard to see 2 spaces. Do you want me to put it as ASCII characters? It would probably be easier to see. Char 32 is a space concatenated with char 32. I don't know if you like that better than 2 spaces. It means the same thing. It's just looking for 2 cases. Which one do you like better? Characters or 2 spaces in quotes? 2 spaces. Okay, we've got 2 spaces. Do until that in string equals, what does in string return if it's not there? InString returns the position where it finds this string inside of this string. Whoops, this has to start at 1. What does it return if it's not there? 0. So we're going to do until it returns 0. That means it's not there. And so inside, we're just going to say days equals replace. Look at days. Look for something, replace it with something. We're looking for 2 spaces, replacing it with 1 space. We're just going to continue to find 2 spaces, shrink it down, 2 spaces, shrink it down, until 2 spaces isn't there anymore. All right, so I'm going to come right back up here and set days back to reading off of 1 line. That loop should compress it down. And now when I look at days, it should be spaced there equally, 1 space between each one, no matter how long. Some of these other suggestions that came up would work just fine. This is a little simpler and a little more general as well. Okay, so at this point, it's not an array yet. Let's make it into an array. So days equals split days. Normally, you come in here and say, I want to split, based on a dash or something. We want to split based on a space, but that's optional. And if we don't tell it what to split on, it assumes to split on a space. And so we can just say days equals split days. We will now have an array numbered 0 through 6 that has my days in it. So day number 3 should be 0, 1, 2, 3. That should be a 7. And so we now have an array structure that has our elements in it. Wasn't too bad, and we did it all with stuff you've seen before. I'm expecting at this point in your programming careers, you would think, wow, I've seen all that stuff before. We've never seen it put together this way. I'm not sure I would have come up with that. That's okay. That's an okay place to be. That's why we're doing this kind of stuff. Just get exposure to these different things. Okay, so now we're on this line here, and we have processed. We've got our days. It's taken us a long time, but we now finally have the date under control. 1 down, 3 more properties to go. All right, so now how are we going to get to our state? How should we go to the state? We've got to find the state. Any thoughts? So one approach would be just read 3 more. If we read 1, 2, 3, we should be able to have it. Yeah, actually, I like that really well. So let's do that. We could make a little loop, a for next loop. For x equals 1 to 3. Do you want to do that? Or do you just want to do it 3? Do you want to do it 3 times?
For next.
You want to do the for next loop? Okay. Declare a variable. We need a control variable. Give x as integer. Hey, while we're making variables, let's make some more. Give x as an integer. Give state as a string. Give city as a string. Give data as a variable. We're going to need data to behave pretty much the same way our days behave. Okay, so x will just give us that will reset my project. Yeah, that's fine. Okay, so I just made 4 new variables: x, state, city, data, integer, string, string, variable. Okay. So now we need to move down. Maybe this probably deserves a comment. Now move down 3 rows to pick up the state. Move. Maybe advanced 3 lines is a better way to say it. Advanced 3 lines to get state. For x equals 1, 2, 3, next, and then we just have to do a line input inside that loop. And so now we've advanced to the state. Sounds like we're in some sporting competition. Ooh, we advanced to state. Okay, now looking at that state, I bet this state is always going to start in the same place. 1, 2, 3, 4, 5, the 6th character. So let's just say state equals the mid of one line, starting at the 6th character. Ooh, we got to tell it how many to take. How many do we want to take?
So you could use in string to determine the position of the character of the first asterisk after the 6th character, which would get S.
We could find out where this character is. We don't want to find this one, so we can say start looking after the 4th character, find the next character. That would work. I got a simpler way to get there, I think.
Is the whole line just those right there? So you can just go to the end, like the length minus 4.
Good. We can find out we can find the length. So in fact, let's ask what the length of this string is right here. I think that's the nice thing about Notepad++. It tells us. We're in column 22. So I think it's 21 characters long. And so how many do we really want? We really want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we've got 21 characters. I'm not quite sure. Let's ask. Question, the length of that data. It's 20 characters. So if we're starting here at the 6th and we want 12 and our length is 20, I think it's just the length minus 8 because we're calculating these 4 characters and these 4 characters. So I think we can say we want it to be the length of state minus 8. That seems a little bit weird because, yeah, we're only chopping off these last 4 off the end, but we're not starting at the beginning. We're starting 4 in. So it's a little more good. But I think that will do it.
Can I ask a question about your for next loop?
Yeah, I'm going to run it.
There's no iteration of the X inside the loop.
Invalid procedure call. Maybe I have this one. Edit, debug. Okay, let's stop that. This part worked okay. Oh, you mean I'm not incrementing X?
Yeah.
Yeah, actually, that's the neat thing about the for next loop is that the next increments that already for me. So the United States Army has brought me water. Just to tell, they're watching all the time. To tell that I was about to pass out. That's my daughter. Thank you, Bethany, for bringing water. No, the water bottle I thought she would bring. It was really easy to drink. Oh, I forgot already. So the next does the incrementing for us. Okay. So we don't have to add the one to it. All right, but I got a problem here. So what was the problem when I got here?
You're using length and state.
Oh, length of one line. Thank you. Run that. Great. Let's see if we got the state correct now. Yeah, we got the state. Looking great. We're pretty sure that's going to be general now. With all this, we're making assumptions about what the rest of the data is going to be like, and so after we run it the first couple of times, we want to look through the data, make sure that it looks right, but we're feeling pretty good about this. Okay, so we got the state. Where are we? Got the state. Let's just advance a couple more lines, and we'll be ready down to our data. We could do a for next loop to do that, but that takes 3 lines, and it only takes 2 lines to advance 2 lines. So I'm just going to do it like this. So, so we've got this data in memory. We'll read this one, throw it away. We'll read this one, and now we've got our first city. This looks pretty good. We're going to start at the 2nd character, and we're going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters, and that's our city. City equals the mid of one line. Starting at the 2nd character, taking, I forgot, was it 12? Taking 12. We'll go back and execute those 2 lines that will advance me across. I should be able to ask for city now. And we've got, I know I'll offend somebody, I'm going to say it like a gringo, though, January. We've got January. Okay, we're going to skip the call. It probably would make sense to actually bring that call number in, but we don't need it for anything, so we'll skip by it. So now we're ready to pull in our precipitation data. Now, we should be looking at this thinking, this looks vaguely familiar. This is going to be almost exactly the same as pulling in our days. So much the same, in fact, I'm going to come up here and take my whole day's loop from the days to the days split, I'm going to just copy that block. I'm going to bring it down right here. I'm going to highlight it, and I'm going to do search and replace. Find days, replace it with data. In the selected text, 6 replacements made, and done. So we'll have an exactly analogous data structure now that's holding my precipitation data instead of the days. Can we follow that okay? I might have done that faster. I will take a drink while you get caught up. Okay. This is feeling pretty good. Now I think we've got all of our data, right? So we've got the date, we've got the city, we've got the state, we've got the data. We've got everything now ready to start writing data out to our worksheet. We'll need a variable to keep track of which row we're on. Scroll back up to the top, and let's dim R as a long integer. We'll go ahead and set R equal to 2 at the top, R equals 2. And we're ready to have a loop that will write out our first block of data. Let's give it a shot. Okay, we've got the data here. For x, so the control variable for our for loop, for x equals 0 to the upper boundary of data. We can use data or days. They're going to be exactly the same size. Next. Cells, row number R, column number 1, dot value is equal to our state. Row number R, column number 2 is equal to our city. Row number R, column number 3 is the date and then the precipitation. Okay, so the date is going to be days sub x, because days is my array. I've got an array called days. I want the 0th position, and I want to concatenate that with mo year. So I'll take the 4, add on the dash November dash 08, and that should give me a full date. And then the precipitation goes in column 4. And that is going to be data sub x. And that's a little error here. It's not day, it's days. So we've got the state, we've got the city. Come back to me, Excel. So for the same state and the same city, we're going to say for the 4th, it's 0. For the 5th, it's 0. For the 6th, it's 0. 7th, 0. 8th is 9, and so forth. That's what this loop is doing. So I should be able to now come back and run this loop, and that should, I don't think my R hasn't been set yet. So let me go ahead and stop this file, stop this, run it again. And I should have some data. Oh, what did I forget to do? It wrote everything to row number 2. What did I forget to do?
Advance the row.
I got to advance the row. So, I even left a blank line for it. R equals R plus 1. I'll run that again. And now we've got our first city's data is right here. We've got the 9 and the 8. The rest are zeros. These are actually entered as dates. Looks wonderful. So now we want to do, let's see, this part here that splits the data. We want this to happen over and over again. Right? Because that's just our first line of data. That was just this line. We've got to keep doing that until what? Until we hit a blank line. We want to keep going until we hit a blank line. So watch this. Actually, we need to move down by 1. That's actually the real trick why I wanted these as 2 separate lines. I'm going to make my loop go right in here. We're going to say do and loop. And I'll tab all that stuff in. So when I first come into this, I'm sitting here on the state. I've got to read 2 lines before I got my data. I read 1 line. I start my loop. I read the next line. I've got my city and my other data. I finish that loop. I read to the next line. And I keep going. I keep doing that. If, let's do it right here. If 1 line equals a 0-length string, then exit do. So that should keep going until I've gotten that whole block. And that loop fits on the whole page. I'm going to go ahead and come up here to the top of my loop and run that. And that should have pulled in the data for that whole first block. Last one is anyone with Portuguese want to help me out here? Juiz de Fora. I know that's not close. Yeah, that was the last one. That's the last one in that block. Woohoo! So I've got the block. Oh, we are so close. I just now have to figure out how to make this happen till the end of the file. Are you ready to do that? It's another loop. Just have to figure out where to put it. Good news is I know where the end of the loop is. The end of the loop is right here. Now I just got to figure out where to start the loop. After we do that, we want to go up here. What do we have to find? We've got to find our next block of data. Truth is, if we could figure it out, we could come right down to here. We could find this. Then we could do, okay, you know what, that might be the right way to do it. So the trouble is, that kind of shows up here as well. So here's what I'm going to do. I'm going to, at the end of this loop, I'm going to put an iterator that looks for norm. Once we find norm, we're ready to, that'll be just like the line that we were on before, we're ready just to advance until we find Sao Paulo. So let's put an iterator right here. Say advance to the next data set. We've got a loop that looks for norm already. I'll just duplicate that loop down here. So once we've advanced to norm here, we've got that norm line. We just have to figure out where to start this loop. So let's go back up here. So here we found the norm. So our analogous place is here. Here's where we're getting ready to make the days again. Folks, the days are the same for this whole file. We don't have to process these days again. And so right here is where we're advancing the next 3 lines to get to the state. That's where I think we need to be. I'm going to put a do right here. And I'm going to tab all of this over. And this looks really great except for one thing. Let's think about where we're going to be when we processed our very last set of data here. So we're going through this. We're processing all of these until we get to a blank line. That's going to let us out of this loop right here. And we're going to hit this loop, which says keep looking until we find norm. What's the problem? There's no more norm. Norm is gone. What do you think is going to happen right here when we say line input and we're done? Take a wild guess. It's going to be an error. So we've got to do something to be able to tell once we hit the end of the line and be able to quit. Here's what we're going to do. As soon as we read a line here, we're going to say, are we at the end? Fortunately, you can ask if we're at the end. Here's how we do it. If EOF, number 1, end of file, then end if. What do we want to do? We want to close number 1. We want to exit sub. We would just exit out of the do, but if we exit out of the do, where does it take us? It leaves us inside this loop trying again. And so if we just exit out of the do, we'd be closing number 1 and we're done. But since it's a little more difficult to get out of 2 loops, let's just close it here, exit the sub. I don't think we're ever going to hit this close number 1, but we'll leave it in there just for case. I'm ready to take this stop out and run the whole thing again. We run that thing. Done running. Come back here, and we should have nigh into 1,000 records, 904 records. We pull all that data, ending with Indonesia Salumakai. Is Indonesia in Brazil? And my geography teachers have some explaining to do. Indonesia, yeah, that's our last one, and Salamki is our last one. Oh, we did that, and we're still a minute early. I know I kind of hurried for that last part, and you may need to be able to compare this if you want to actually get this running for yourself. The good news is I'm going to post it on Learning Suite, and you'll have access to it. We're going to talk about something. Oh, we're going to talk about postponing the